One of the types of word problems that you should be able to answer are mixture problems. And mixture problems are always set up in kind of the same way. They build up. The problems themselves kind of work out the same way too. So we have the question. A chemist has 8 liters of 25% saline solution. So that means she has a solution, some liquid, that's 25% salt. Think of salt water. So there's 25% salt water mixed in. She wants a mixture that is 40% saline. How many liters of a 70% saline solution should she mix with the 25% solution? She has 25%, she has 8 liters of that. She's going to mix in some 70% saline, and she wants the result to be 40% saline. There's 2 ways to approach this particular type of question. In the video that you saw previously, you learned about this first method. We'll go over that, and then we'll go over an alternative. So, in the video that you learned, or that you saw originally, we thought of this as like a giant seesaw. The idea being that we have 25% on one end, 70% on the other, and we want 40% in the middle. So we made kind of a mixture picture. So this is 40%, that's the desired goal. We have 70% on this end, and we have 25% and on this end. And the question was really, how far away on either side are we on these 2 sides? How far away from the 40% to the 70% versus the 40 to the 25%? And that kind of affects how much of both we need. So we look at the idea here, we get 40 minus 25 is 15. So that's 15 here. 40 minus 70 is 30 over here. And just like with a seesaw, if you have 2 people sitting on it, one very, very large and one very, very small. If you've ever been on a seesaw with like a younger sibling or something like that, you might have experienced this. You can actually get each other to balance as long as the smaller person is much, much farther away. The farther out you go, the less weight there needs to be in order to get the other person to be lifted up in the air. So whatever larger person, we're going to need less of that than there is of the smaller. So that's kind of a clue as to what's going on here. We think of the larger percentage here, and we think of this difference as actually being the distance away on the seesaw. So we have then that 15 times 0.25, 0.15 times, nope, I'm missing some information. Hold on. I also need to say that there's 8 liters of this, there's an unknown number of liters of that, and so the resulting will be H plus X. That's what I need. So this is 0.15, 15%. 15% times 8 should be balanced with 30% times X. We take the amount times the distance equals the amount times the distance. It's the same idea here. Weight times distance should be equal weight times distance. The smaller this weight is, the larger the distance needs to be. So we have this particular setup. 0.15 times 8 is 1.2 equals 0.3x. Divide both sides by 0.3, and we get 4 equals x. So she would need 4 liters of the 25% of the 70% saline solution to mix it in with the 25%. She'd end up with 12 liters overall. So this is one way to answer the question, but this may not be satisfactory to you. This may not make sense as to exactly why this works. So I wanted to show you another method. Another method for how we could solve this. And the way that we solve this is kind of thinking in terms of how much salt are we actually talking about. Remember, saline means salt here. We have 3 beakers. Think of your science class. We have 3 beakers. We have this one, which is 8 liters. There's 8 liters of that. This is 25% saline. We have another amount that I don't know how much I have of. This is 70%. And we have a third amount that, again, I don't know how much has, but this is the goal. It's 40%. The point is I'm going to be adding these together. I'm going to be combining the 8 liters of the 25% saline and the unknown number of liters of the 70% saline to get the 8 plus X liters of the 40% saline. So we can pretty much set it up just like this. We know that 25% of the 8 liters is salt. So that means 25% of 8, there's that amount of salt. Amount of salt in mixture 1. We don't actually know what the amount is in beaker 2, but we know that 70% of that is salt. So we can say 0.7x. This is the amount of salt in mixture 2. The resulting amount we want to be 40%. 40% of 8 plus x. This is amount of salt in final mixture. This is based just on percentages. 25% of 8 liters. It's 25% saline. There's 8 liters. That means there's 2 liters of salt. We actually took 2 whole liters of salt and dumped it in with water, or whatever the liquid actually is, mixed it up to get that 25% saline. We had 70%, whatever this is, was salt. And we want 40% of whatever the total amount is going to be of salt. And so this is our equation, 0.25 times 8. So 2 plus 0.7x equals, we distribute, 0.4 times 8 is 3.2 plus 0.4x. That's our equation, and from here it's pretty easy to solve. Subtract 2 from both sides, subtract the 0.4 from both sides, we get 0.3x equals 1.2, which should look familiar. Divide by both sides by 0.3, as we did before, and we get x equals 4. So we'll use 4 liters of the 70% saline solution to mix in. So make your equation, if you're having trouble with this seesaw method, make your equation, set it up in such a way that you're looking at what percent of acid or saline or whatever the stuff is that's in the solution. Actually, how much of that stuff are you talking about? Again, 25% of 8, 70% of x, and 40% of the 8 plus x, the total overall mixture. We'll do one more example.